Derivatives with exponentials, product rule, Lagrange's notation. So here we have a to the power of x. That's our function. When we go to derive it, we end up with ln of a multiplied by a to the x. A resembles is a real number. So a 7, a 10, a 13, whatever. And when you derive that, you get the natural logarithm of that number multiplied by that number times to the power of x. This is a rule we'll be using, and this is the product rule that we'll be also using in this tutorial. So let's start with an example. This won't be a product rule, this will just be showing you an example of this question. See how that works? You have a number to the power of x, and when you derive that function, you get ln of that number multiplied by that number to the power of x. Essentially, this, when you derive it, stays the same, but then you multiply it by ln of the number. Okay, that's just the generally, that's just the rule. So now we'll implement that rule into a product rule, Let's say we have 4 to the power of x multiplied by x to the power of 4. We have our first function, we're multiplying it by our second function. If we were to separate the page, fx will label as 4 to the power of x, and gx will label as x to the power of 4. So if we write out the derivative equation, what we get is the derivative of fx multiplied by gx plus fx multiplied by the derivative of gx. This says we need to find the derivative of fx and the derivative of gx in order to complete this equation. So the derivative of fx, if fx is 4 to the power of x, the derivative would be ln of 4 multiplied by 4 to the power of x, just like before. Derivative of gx, if gx is x to the power of 4, the derivative would be 4x to the power of 3. If we input these values into this equation, what we get, derivative of fx, ln 4 multiplied by 4 to the power of x, multiply that by gx, x to the power of 4, plus fx, 4 to the power of x, multiplied by derivative of gx, 4x to the power of 3. Simplify this a bit more. Because there's a 4 to the power of x multiplied on both sides of the addition sign, we can factor it out. And have it looking like that. That's the first derivative of this up here. We do a second example. Or more like a third example. Okay, so say we have e to the power of x multiplied by 10 to the power of x. We have our first function and our second function. If we separate the page and label them, we get e to the power of x is fx, and for gx we get 10 to the power of x. The derivative of hx is the derivative of fx multiplied by gx plus fx multiplied by the derivative of gx. Therefore, in order to complete that, we need derivative of fx and the derivative of gx. The derivative of e to the power of x is just e to the power of x. I have a video on this, but if you need to know why or more about it, but I'll just continue in this video. The derivative of gx is ln 10 multiplied by 10 to the power of x. Same as before, we have ln times the number multiplied by the number to the power of x. In this case, the number is 10. And if we input these values, derivative of fx, ex, e to the power of x, multiplied by gx, 10x, 10 to the power of x, plus fx, e to the power of x, multiplied by ln, 10, multiplied by 10 to the power of x. Now, because we have both an e to the power of x and a 10 to the power of x multiplied on each side of the addition sign, we can factor that out. Essentially, if we expand these brackets, we'll get that. So if we times these two by 1, we get that. If we multiply these two by ln of 10, we get that. For the fourth example, let's say we have sine x multiplied by 17 to the power of x. We have our function sine x multiplied by our other function 17 to the power of x. If we label fx as sine x and gx as 17 to the power of x, write out the formula or the equation for the product rule. First derivative is f dash x multiplied by gx plus fx multiplied by g dash x. Finding f dash x and finding g dash x. The derivative of sine x is just cosine x, and the derivative of 17 to the power of x is just ln 17 multiplied by 17 to the power of x. If we were to input these values, derivative of fx, cosine x multiplied by gx, 17x, plus, I'm not going to fit that in, plus derivative of just fx, sine x multiplied by the derivative of gx. ln 17 multiplied by 17x. We can factor, because there's both a 17 to the power of x on both sides of the addition sign, we can factor it out. And that is our first derivative of this function up here. Thanks for watching. I hope this helped.